Hello, in a previous video I had shown how to use this WebPlotDigitizer of Automeris to extract the data of a polar plot like this one here. And I would just like to give another brief tutorial because this picture is a bit tricky because of the used colors and the legend and the tick mark labels here. So let's try to load this image into the WebPlotDigitizer. It's called pattern PNG, and then we need to select that it is a polar plot and we need to calibrate it first. So I will select the origin and then two other known points. For example, here at 0 degree and 0 and at 90 degree and -10 approximately. And then we will say, okay, this is 0 and -10. And then the other points here are 0 and 90 degree, and it's clockwise, right? So now we can click calibrate and we can try to detect the colors. And then you can see it's the dominant colors here are blue and red, and I can click on this blue. But if I take this tool here and select the real blue, then it's a bit of a different color. And yeah, so if I run, then it will detect almost each and everything. Of course, I can lower the color distance here to maybe something like 20 instead of 120. Then it will select only this, which is good, but it will also select here the legend. And the same happens if I pick the red color. Right, so this was now the red color, and I can pick the red color from here. And once again, you can see that these numbers slightly change. And if I run, then it also detects the tick marks and this legend here. So we need to change this figure a bit first. And therefore, I will go into this XnView software and at first check how many colors are inside this figure. And it's quite a lot, 192 colors. So the first thing that I will do is, this was wrong. I want to reduce the colors. So I will go here to colors and then reduce the number of colors to 8. And then obviously nothing changes except for that the figure has only 8 colors. So let's save it as pattern 8. And then I will use another great software that has always been around in the Windows world, Microsoft Paint. Paint is your friend. And so with this Paint, it's super easy to now give this line and this line a different color. So I will select something that is strongly different from the background and from the grid and so on, like yellow. And then we can use this tool here to paint this line yellow. And I will select another color, maybe like this green, and we'll paint this red line green. So now only the line and only this line is yellow and green, and I will save this figure as under a new name, for example, pattern 8 yellow green. And now we can go back to the WebPlotDigitizer. We need to load the image once again, select the new image here. Then, of course, we need to calibrate again. So once again, calibrate the origin, the known point at 0 and 0 and at 90 and -10, which is approximately there. The values here are still the same. So I can calibrate. We can pick the colors, and now you can see that yellow here is detected, and if I click on this yellow line, the values do not change. So I can run and only the yellow line is detected, and then I can lower this pixel distance here a bit so we get a better resolution. If I lower it even more to maybe 3, you can see now that the line, because the line is too thick, sometimes two values are selected very close to each other. So the line, let's say, somehow doubles, which is not good. So I will go to delta x and delta y approximately 4, which looks good. And then we can view the data. We can sort it, for example, by the angles, and then just download the comma separated values file. And this is the right hand cross polarization, I guess, is what this abbreviation means. This is an example that someone sent to me via email. So I will save it, click close, and then we can do the very same with the green line. So if I click on green here, and if I once again click on green in the figure, you can see that these values here do not change. And once again, I can run, and then you can see, oh, unfortunately, this green is still too close to the grid color. So if I use less color distance, like this 20, then really only this line is selected. If I go down to 3, the line somehow doubles. So 4, I mean, it's the same line width. Why should it be different? This looks good. I can view the data. I can sort it by the angle theta and download the comma separated values file under LHCP and save it. And I think you can, I don't know where you can change the data format, but if we go to the folder and now check what is inside these comma separated values files, you can see that we have theta and the radius. And maybe what you would need to change here is you might need to go and select all the commas and replace them by dots. And so now you should be able to import this comma separated values data file into MATLAB, into Octave, into Python, into whatnot, and plot it there without any problems. And this is, yeah, to replicate this polar plot here and to maybe compare it with other simulated or measured data. And this is what I would like to show in this short video.